everybody, this is me Vinu Venkatesh on behalf of the Sai Education for Competitive Examinations. So let's continue our discussion on the number system. Today is the last part of the lecture. I hope you've been following our lectures. Please do give us your comments, and I think without further ado, let's just start. Alright, number 42. We left at 41, we finished 41. Number 42. Again, here also there's a formula. The mean of 1 cube plus 2 cube plus 3 cube plus 4 cube is how much? Use this formula where n is the number of terms. It is 4. So 4 multiplied by 4 plus 1 whole square divided by 4 will give you 25. You'll have to memorize these formulae, okay? Because without that you can't do this question. You simply have to memorize and apply it. Next, the mean of squares of consecutive odd numbers till 9 is what? Use this formula. When you simplify, you get 30. N times n plus 1 divided by 3. N is 9. That is the number of terms. 9 into 9 plus 1 divided by 3 will give you 30. The average of, this is of, not of, square of consecutive even numbers till 16 is what? N plus 1 into n plus 2 divided by 3, where n is 16. Once you solve it, you will get 102. Okay, you have to memorize this formula. There's no other way out, right? Number 45 is very easy. You can do it yourself. Find this and find x. I'm not explaining. Number 46 is also simple, which you can do by yourself. Alright, so 51. Okay, before 51, I want to introduce a couple of new topics. It's called arithmetic progression and geometric progression. Okay, what is arithmetic progression? It is a sequence of numbers such that the difference between the consecutive terms is constant. What are consecutive terms? Remember, I said numbers or terms which occur one after the other. For example, 50, 51, 52. They are consecutive numbers. 50, 60, 70 are not consecutive numbers because they do not come one after the other. 101, 102, 103 are consecutive numbers. Okay. So, for example, this means that, for example, it is numbers like 2, 4, 6, 8, etc. So, these are consecutive terms and the difference between them is constant. 4 minus 2 is 2, 6 minus 4 is 2. So, this is a type of a pattern, a series. So, we have a formula. So, in such cases, we have seen a lot of questions. We will see many more. Normally, we are asked to find the nth term of this series of the arithmetic progression. How do we find it? Let the nth term be an. We take the first term, which will be given to you, plus n minus 1 into d. What is n? N is the number of terms. They'll give you a question. They will give you a series like this, and they will say brackets first of, then division, then multiplication, then addition, then subtraction. That is why it is called BOD-MAS. Okay, keep it in mind. You have to follow it all the time, because if you do it in any other way, you will get the wrong answer, as we just saw. Okay, which is the largest number to get the same remainder by dividing 834 and 663? This is question number 50. So there is a technique of doing it. You have to know the technique. You subtract the two numbers, you get 171. Find the LCM of it. Okay, and then multiply that. You will get the LCM as 171. So 171 is a correct answer. There are no questions to be asked here, because this is a way of doing it. You'll have to know this way. The more you do it, the more you'll come to know. All right. Okay. Number 47, very simple, but it follows a very important principle in mathematics called BOD-MAS. We have discussed it before, but I'd like to do it a little more now. BOD-MAS. B stands for brackets, O stands for off. Off is the same as multiplication, but sometimes they give 3 by 4 of x. It means the same. D is division, M is multiplication, A stands for addition, and S stands for subtraction. So in questions like this, where there are many operations means multiplication is there, addition is there, division is there, which one do we start with? We have to start in this order. So if there are brackets first, then off. If it is given, it will be given as off, don't worry. then comes division, then multiplication, then addition, and then subtraction. So for here, what comes first? Division. So first divided by this, then comes multiplication. Multiply this, you will get 0.16, then you add, you get 0.26, which is the correct answer. If you do it in any other way, it will be wrong. Suppose if I divide this first, right? 0.4 into 0.4 plus 0.1. If I add it, okay, I will get a different answer. It is 0.2, and that is wrong. BODMAS has to be followed in all situations. So keep that principle in mind. It's very simple. So the correct answer is 0.26, which we got. 48 also involves BODMAS. I want you to try it on your own. Same with 49. Okay, so it's very important. Very simple, but very important. I hope it is clear. Brackets, they will give you a series like this and they will say find the 10th term. So how do you solve it? First term is 2 plus 10 minus 1 into d. D is the difference between the consecutive terms, which is 2. You will find the nth term. Okay, this is called arithmetic progression. Let us see an example. We have done this before. Similar question. In an arithmetic progression is also called AP. The first number is 105. The difference, that is D, is 7. Then what is the 128th number? So they have already told us that it is arithmetic progression. We can directly use a formula. Here they have used capital A, but you can use small a, A1. So what is A1 here? 105 plus N now. What is the number of terms? 128. Minus 1 into D is 7. This is, the answer is 994. 994 is the 128th term or number in the arithmetic progression. You'll have to memorize the formula, but I hope the concept of arithmetic progression is clear. There are some other questions. I'm skipping to number 60 because it's also relating to AP. So how many natural numbers between 17 and 80 are divisible by 6? So how do we know that this is a question of arithmetic progression? In arithmetic progression, what do we need? We need a series of terms, consecutive terms, where the difference between the terms are equal. So is this an arithmetic progression? They're talking about natural numbers. Okay, between 17 and 80. That means they are consecutive numbers, right? And the difference between each number is 1. So it is the same. Now they are saying let me go back. They're talking about numbers between 17 and 80 which are divisible by 6. Okay, what do you mean divisible by 6? Now how do you, okay, if I take these numbers, okay, 12, 18, 24, 30. These are all numbers divisible by 6. Okay, what is the difference between these numbers? 18 minus 12 is 6, 24 minus 18 is 6, 30 minus 24 is 6. So generally, when you're talking about numbers which are divisible by one number, the difference between the consecutive numbers is equal to the divisor. So that means the difference between each of these terms, consecutive terms, is the same. That means it is an arithmetic progression, right? So what are we given here? We are given, so first thing we have to find out is, in this series of numbers, what is the first number that is divisible by 6? Is it 17? No, it's not. Is it 18? Yes, it is. So A1, as per our arithmetic progression formula, is 18. Is 80 divisible by 6? No. Is 79 divisible by 6? No. 78? Yes. 13 into 6 is 78, right? So we have got the necessary figures for our formula. So A1 is 18, AN is 78. That is the last or the highest number divisible by 6 in that series. The difference is 6. So how many numbers do we have in this series? Let us substitute. We know AN is equal to A1 plus N minus 1D. Substitute the number. 78 equals 18 plus N minus 1, 6. Solve for N. You will get N as 11. Here, you have got, they have used this formula. This is nothing but the same formula that we have used, but arranged in a different way. Oh, sorry. N is 11. this is the same formula that they have used but arranged in a different way. dn is nothing but an, di is nothing but ai, and d we know, and then you have 1. Okay, it's the same formula arranged in a different way, so you can use the same formula. So this is similar to question number I think it was 34. Very similar to that, right? I hope this is clear now. Now 61 is also similar. Please use the formula. Please first identify whether this is arithmetic progression or not. In this case, A1 is simply 6, AN is equal to 105. What is the difference? It is 9. See if it is the same throughout. Only then it is arithmetic progression, and only then can you use this formula. Moving on to number 62. Okay, before that, now I want to talk about geometric progression. We have learned what is arithmetic progression. Let us learn what is geometric progression, or GP. It is a sequence. What is geometric progression? It is a sequence. Geometric progression is a sequence of non-zero numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. So here in geometric progression, this is also a sequence like arithmetic progression, okay, of non-zero numbers, okay, such that each term after the first is formed by multiplying the previous number by a fixed non-zero number called the common ratio. So here, look at this, for example, okay, these are all non-zero numbers. In this sequence, each term is found by multiplying the previous term by a fixed non-zero number called the common ratio. For example, AR is equal to A into R, the previous term A into a fixed non-zero number called R, which is called the common ratio. R can be 100, R can be 1 by 2, anything. It just has to be non-zero. AR cube is equal to AR square into R. So each of these terms after the first one is got by multiplying the previous term by a fixed non-zero number called a common ratio. In this case, it is R. See, R is not equal to 0, and it is the non-zero common ratio. So this is a difference between arithmetic progression and geometric progression. In arithmetic progression, it is a sequence where the difference between the consecutive terms is constant. Geometric progression is a sequence where after the first term, the subsequent term is arrived at by multiplying the previous term by a fixed non-zero number called the common ratio. Okay, so find the sum of this sequence. So we see if it is a geometric progression. Are they all non-zero numbers? Yes. 2 is non-zero. 2 raised to 10 will definitely be non-zero. Okay. Now look at each term. Each term is obtained by multiplying the previous term by a fixed non-zero number. 2 square is equal to 2 into 2. 2 raised to 4 is equal to the previous term multiplied by 2. So 2 is the common ratio. 2 cube into 2 is equal to 2 raised to 4. So this is a geometric progression, right? Where A is equal to 2 and R square is also equal to 2. A is the first term. R is the common ratio, or the fixed common non-zero number that we multiply each term with, right, to get the next term. So how do we get the sum of the sequence? It is this formula: A into R raised to n minus 1 divided by R minus 1. So A is 2, R is also 2, so 2 raised to 10. N is the last exponent, minus 1 divided by 2 minus 1. Solve it, you'll get 2046. So I hope you've understood what is a geometric progression. You have to learn this formula. Also know what is arithmetic progression and when to apply this formula. Alright, so we're back. We left some of the questions in between. So 52, 53, 54, very simple. I would like you to try it on your own. 55, okay. Now whenever you're given these huge numbers, try to find out if there is a shortcut way of doing it, okay. Now 9959. So what is a shortcut way? Shortcut way is simply 5793405 into 1 lakh minus 5793405 will give you this number, right? And that will be your answer because it's a huge number, 5793405 into 9959. Another way is here in these choices, the obvious answer is A. Obviously, because you know that the answer is going to have more than 3 digits, definitely more than 1 digit, definitely more than 4 digits, because the numbers themselves are 4 digit and 7 digits respectively. So answer is definitely going to have more than any of it. So obviously the answer here in this case is A. But suppose if you are given similar choices, then you have to use these kind of shortcuts. Okay. Number 56. Now look at this question very carefully. See if it follows any formula or expansion of a formula. 976 into 237 plus 976 into 763. How can we simplify it? What is common here? 976. So please take it out. Open brackets, 237 plus 763. This will give me 976 into 1000, which is 9,76,000. Isn't it simple? Yeah. So always look for ways of doing it. Maybe you have to expand it. Maybe you have to use a formula. You have to keep thinking. All right. Another way of doing this is you can write this as 579. Now going back to 55, you can solve 55 in another way. You can do it in the same way as 56. You can write 9959 as 1 lakh minus 41. Sorry, you can write this as 10,000 minus 41. Right? Yeah, you can write this as 10,000 minus 41. Multiply this by 10,000 minus this by 41. Then it will be easier to solve this question. All right. Did you understand what I'm saying? I'm saying 5793405 into 9959 can be written as 5793405 into 10,000 minus 41, because 9959 is equal to 10,000 minus 41. Expand it, it will be this into 10,000 minus this into 41, which should give you the same answer. All right. Okay. Now 57. Okay. Remember we talked about the formula of finding the dividend in a given term. Dividend is equal to divisor into quotient plus remainder. This is the same thing, but they've written it differently. You have to simply apply the formula here in this case and you'll get this answer. So I'm not going to do this. 58 is similar to 26, so you can do it by yourself. 59 also we have done, but let's do it again. What is a unit digit in the product of this? Okay. What is a shortcut? Take the unit digits of each number, that is 4, 9, 3 and 6. Multiply it, you will get this answer. Take the unit digits from this product and that will be the unit digit of the product of the entire thing. So 8 is the answer here. There is no explanation as it is. It's only a shortcut and you'll have to memorize the ways of doing certain things. Right? So that brings us to the end of the number system. Please let us know if you have any questions or comments. Put them in the comment section. Keep practicing. Learn the formulae. Good luck and see you next time.